For more information on tutoring, personalized video solutions, or how to support Moof University and the production of more videos, please visit moofuniversity.com. Thank you and enjoy. Okay, so some of you may already be somewhat aware of what's going on with this, but you can use the periodic table to help you figure out what's going on with electron configurations. In fact, we can split the table up into blocks that really help us figure out what's going on. The first thing we have to do is kind of imagine helium. Let's do this in a different color. We kind of have to imagine helium being right over here in this little space. Okay. Once we imagine that, it's actually pretty easy. So let's scroll down here. We get what's called the S block, P block, D block, and F block. So the S block is really just the first two columns, right? The D block is basically the transition metals, and the P block is the nonmetals over to the right, or at least most of them are nonmetals. Actually, maybe not most of them. A lot of them are. Anyway, the S block is 2 columns. The D block is 10 columns. The P block is 6 columns, and the F block is 14 columns. What's going on there? Well, let's think about this. We got 2 columns here, 6 columns here, 10 here, and 14 here. Basically, every time you move over one element, you add 1 electron. So here, this would be like the NS2 situation. Here we have the NP6. Here we have the ND10s. And here we have the NF14s. So let's kind of put all this together and see what actually is going on. Okay, basically, we go through and we fill this accordingly in this order. So we have 1s1 and then 1s2, and then we go to the right, and then we do 2s, 2s1, 2s2, and then 2p, 2p1, 2, 3, 4, 5, 6. Then we go to 3s, 3s1, 3s2, and then we go to 3p, 1 through 6. Then we go to 4s, up to 2, and then we do 3d all the way up to 10. Then we do 4p up to 6, and then 5s up to 2, then 4d up to 10, then 5p up to 6, then 6s up to 2, and then there's this little block here, okay? And that's because this green F block is supposed to actually insert right there. So after 6f, we go to 4f, and once we finish 4f, we go to 5d, and then we go to 6p. After 6p, we go to 7s, and then we drop down to 5f. After 5f, we have 6d, and after 6d, we've got 7p. Okay. So let's use this to do some configurations. Let's start with PM, which is promethium. Okay. So atomic number of 61. So that's down here in the F block. Number 61. Okay. So everything up until xenon is going to be filled. So let's start up at the top though. Hydrogen, helium, that's 1s2. So we'll have 1s2. Then we'll have 2s, lithium and beryllium, 2s2. And then over here, 2p6. Then 3s2 starting with sodium and magnesium, and then 3p6, and then 4s2, and then 3d10, and then 4p6, and then 5s2, and then 4d10, and then 5p6. Then we have 6s2 at cesium and barium. Then we've got 4F, so we drop down here. Then we have La, Ce, Pr, Nd, and then M. So that's 1, 2, 3, 4, 5. So that's going to be 4F5. Of course, we can shorten that to just Xe, right? Xenon. And right after that, there's 6S2 and then 4F5. So that's it for that one. Let's try HF, which is hafnium. So 72. So that's going to be everything up until xenon as well. So I'm just going to fill everything in up up to just before 6s the same way. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s, okay, so cesium, barium, 2, 4f, so the hafnium, the HF, is after this, that's part of the 5D portion. So I have to drop down to 4f, go through all 14 of those, and then I start with this Lu over here. This Lu kind of actually has to be, you can imagine this, it's actually supposed to be right before the hafnium, right here, okay? So what that would be is that would be 4F14, and then 5D1 at the 71 with the Lu, and then 72 comes right after hafnium. So that's 5D2. So the abbreviated version would be xenon, and then 6s2, 4f14, and 5d2. For lead, notice that lead is in the same row as hafnium, and it's after it, right? Lead is over here, 82. So it follows hafnium. Hafnium is in the 5D portion, right? 5D row. So the 5D row completes before lead, right? So everything up until 5D is complete. Everything up through 5D is complete. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, 5d10. Then how many are in the P? Well, there's TL and then PB, so that's 2. Okay. So we've got everything up through xenon, and then 6s2, 4f14, 5d10, and 6p2. So that's the electron configuration of lead. So it's an important note here. It's important to note here that using the Aufbau principle guidelines, you will get the expected configuration, which is what we got here for all of these. Now, doing that won't always give you the actual configuration, especially when it comes to D and F block elements. They can get kind of crazy. But you have to just know that oftentimes when you're asked questions about an electron configuration, you're really asked what is the expected electron configuration, because you're using the Aufbau principles. So I hope that video was helpful. Thank you for watching. If you found that video helpful, don't forget to like, comment, subscribe, and share with friends. Thank you and happy studying.